In this challenge, you'll have the opportunity to design, test, and decorate your own energy-efficient house. Buildings are designed to keep the indoor air separated from the outdoor air. Otherwise, whatever form of heating and cooling system you have is trying to heat or cool the air outside the building as well. When your parents yelled at you for air conditioning the outside, they weren't wrong. That would be terribly inefficient. Buildings are constructed out of materials that insulate or block thermal energy transfer. Insulating materials do not conduct thermal energy well. Since it does not conduct the thermal energy, it traps that thermal energy, kind of like a thermos or Yeti mug. The parts of the building that separate indoors from outdoors construct the building envelope. The walls, floor, roof, doors, and windows are part of the building envelope system. Their purpose is to keep the interior of the building a comfortable, healthy place to work or learn while allowing access into and out of the building. It's easy to trap air when you have a fully closed system, but when you have doors, windows, etc. opening and closing all day, it's hard to keep that air in one place. The space above the ceiling, below the floor, and within the walls is filled with insulation, which prevents thermal energy transferring. Insulation is graded by its R value, which is an abbreviation for its resistance to conduction. In order for the building envelope to do its job, air must not be allowed to flow into or out of the building. The most obvious way to avoid air infiltration is to keep doors and windows closed when the heating or cooling system is running. Doors and windows that leave gaps, even when closed, need a strip of weather stripping to seal those spaces. The space between doors or windows and the walls that contain them also need to be sealed. Immediately after a building is completed, the doors fit snug in their respective spaces. Over time, however, the building expands and contracts slightly as it heats and cools with the seasons, and the doors may not fit as tightly anymore. Therefore, it's important to inspect these junctions annually and fill any gaps with weather-tight caulking. Many buildings, such as schools, apartments, and condos, have two sets of doors at each entry point. These vestibules prevent large amounts of air from rushing in or out of the building as people enter and exit. To work properly, though, both sets of doors need to be kept closed when they're not being used. You can test the envelope of your home by putting a dollar bill in your door. If it slides out easily, your door may need some insulation. Weather stripping makes that seal nice and tight, so when I put the dollar back in, it sticks. Windows made of metallic frames were often used in buildings built in the 1950s and 1960s. The aluminum in the frames is an excellent thermal conductor and will conduct energy right through to the other side, breaking the seal of that building envelope. As you can well imagine, this is not a great material for constructing window frames. Most windows today are made of vinyl, wood, or composite materials that are better insulators. Low-E glass has a special reflective coating that reflects ultraviolet light. Ultraviolet light that can come through is trapped in the space and transformed into thermal energy. Think about the inside of a car on a hot sunny day. If light reflects off the window, it can't transform into heat and can't be trapped inside the car, or in this case, your house. The number of panes of glass in a window is important too. Single pane windows are not well insulated. Double or triple pane glass has an insulating space between the glass that allows light in and keeps thermal energy from transferring across the window. This space is usually filled with air or other gases that create a big insulation barrier between the inside and outside. If you ever feel air moving through the area around a window on a windy day, there may be small gaps in the window materials. Weather stripping and caulk can often be used to patch these gaps and seal that building envelope right up. To count the number of panes in your window, you can hold an object and count the number of reflected images. In this case, there's 2 images, so there's 2 panes of glass. That means there's a gap of air in between to help insulate the inside and the outside. Geothermal is exactly what it sounds like. Geo, earth, thermal, heat. It's heat from the earth. As the core radioactively decays and the amount of pressure from all the rock on top, it creates a lot of heat below. This keeps the earth, or the mantle below us, relatively the same temperature. We can use that heat, that naturally existing heat energy, to heat homes, grow crops, and even generate electricity if we can generate enough steam. Here's an image of a geothermal power plant. On the right, we have a couple examples of homes that are heated using geothermal energy. These homes use the natural heat underneath the earth instead of burning natural gas. Let's take a little field trip to energy manager and expert Jim Brown's house. His home is heated using geothermal energy, but then he contains that energy using very specific tactics. See if you can pick them up.
So our house is heated with a geothermal system, which takes the constant temperature of the earth as a starting point, roughly about 55 degrees, to heat or cool our home. It also has what's called a desuperheater, which takes the leftover heat after that to preheat our hot water. And so that goes to a preheat tank here, and the preheat tank then goes into our electric hot water heater. The rated guide on the electric hot water heater is $573 a year for a total of 4,773 kilowatts per year. So far in 4 years, we've yet to reach that 4,773 kilowatts, so it kind of shows you the effectiveness of the system. It is a forced hot air system, and our house is sealed very well. Typical homes, Energy Star homes, are rated for 3 air changes per hour at 50 pascals. Our home is under 1 air change per hour at 50 pascals. Because of that, we have a heat recovery ventilator. So all the fans in our bathrooms, the air that is pulled out of the bathrooms goes through this, and the air streams don't actually interact with each other, or they don't mix. The air doesn't mix, but they pass over each other, and 70% of the heat is recovered in incoming air to the house. So that's anytime air is brought into the house, it's heated from the outgoing air. Our windows have low E glass, which minimizes the amount of ultraviolet and infrared light that comes in through the windows, and it doesn't affect the amount of light that comes in. For the unfinished portions of our basement, we have what's called blanket insulation. It's a cheap and effective way. But then for the areas between our floor joists, we have spray foam insulation, which is much better at sealing and insulating, has a high insulation density.
You've been sent some building materials. To build the basic structure of your home, you have a box and a roll of tape. Your goal is to seal the house's building envelope. To do that, you have many insulation material options. Each material insulates differently. It resists that exchange of thermal energy differently. To cover your walls, floor, and ceiling, you've been sent poster board. And to build transparent windows, you have transparent paper. Your doors and windows may get drafty, so you may need some weather stripping. Here are both clay and foam options for you to try out. You aren't restricted to using just these materials, but there are a few bare minimum building codes that you must follow. Your building can be assembled however you'd like, but it must be a closed system, and you must use the box that you were sent. Your house must have one 10 centimeter by 20 centimeter vertical door that opens and closes. You can add a storm door, but both doors must be able to open and close. Your house must have two 10 centimeter by 10 centimeter windows. These windows do not need to open, but must be transparent. We must be able to see through the windows. For your doors and windows, make sure that you measure twice, cut once. When you cut safely. If you're using scissors, start a hole with a pencil and then continue to cut. If you use a tool that's more technical, like a box cutter, make sure you have parent approval and supervision. To seal that building envelope, insulate all surfaces in your house to separate inside and outside air. However, all walls, floors, and ceilings must be covered with poster board, so the insulation is inside the wall. The poster board acts like drywall. The walls also cannot be thicker than 1 centimeter, including that poster board and all of the insulation. This is the bare minimum energy house. It's a closed system with 2 transparent windows and a door that opens and closes. You can get creative as long as you follow this building code. Once the house is insulated and as energy efficient as you can make it, you can decorate the house and give it some curb appeal. An energy efficient house only saves energy if someone wants to live in it and buy it. Focus on decorating only the outside of your house and only after you've made it as energy efficient as you can. To test your house's efficiency, measure the temperature inside the house as a baseline to begin. Next, place 8 standard ice cubes in a sandwich bag and place them in the center of your house's floor. After 10 minutes, measure the temperature of your house again. Because all houses are using the same amount of ice, all houses have the potential to cool the same amount. So the house that's most insulated will cool down the most because it keeps the warmer air out and the cooler air in.